In this short segment, I want to show recursion over expressions in a first example, and that is of pretty printing. So we talked about going from an expression to a string. So going from that structure, for example, add of num2 and the expression mul of num3 and num4 to the string parenthesis 2 plus, etc. We can visualize this happening bottom up. So we can think, okay, we know how to print the numbers 2, 3, and 4. And once we know how to print the objects that are part of a complex expression, we can begin to bottom up pretty print the more complicated. So once we know 3 and 4, we can pretty print the next level up, because that's parenthesis 3 times 4 close parenthesis. And then finally we can print the top level because we know how to pretty print the 2 levels below. And so we get the result that way. So you can think of this recursion as working bottom up. You can also think of it working top down. So, and this was how I explained recursion when we talked about it earlier for lists, that we can think, I know how to print the whole expression as long as I know how to print the sub-expressions. So, for example, here I know that what I will print is parenthesis, then something for the left side, then plus, then something for the right side, then closing parenthesis. And I can rely on recursion to give me the things on the left-hand side and the right-hand side. So on the left, I can immediately get 2. On the right, I will get 3 times 4. And so I can fit those in and get the answer 2 plus 3 times 4. So I can define, as long as I know how to get from the top level, one level down, that will allow me to print the whole expression. So let's look at how that turns into a definition. We're writing a function which takes an expression and returns a string. How do we print a simple number? Well, the answer is we turn that number into a string, and to do that we use show. How do we print a variable? A variable is a single character, and remember that a string in Haskell is a list of characters, so we simply put that variable into that character into one element list. So those are the base cases. We know how to deal with a number and a variable. How about dealing with an addition? Well, on the previous slide, I think I showed you that we can think about the addition will be a parenthesis, followed by how we print the left-hand side, followed by a plus, followed by how we print the right-hand side, followed by a closed parenthesis. So we can see, and this is how recursion works, we define the print of an add with 2 sub-expressions, assuming we've got the function defined on the sub-expressions. And in exactly the same way, we can print a multiplication. So that gives us our recursive definition. I could have written another template for this, but you can begin to see, I don't think I need to write a template for you to see how you can, how these recursions will turn out.